Today, I'm going to try and play the tuba. That's me playing the tuba. Today's lesson is number sequences. We're going to describe the patterns in arithmetic and geometric sequences and use the patterns to find terms. A sequence is a set of numbers that follow a pattern. An arithmetic sequence is a sequence where each term is found by adding a fixed number to the previous term. A geometric sequence is a sequence where each term is found by multiplying a fixed number to the previous term. A conjecture is a prediction that suggests what you expect to happen. Pause the video so you can finish writing down these definitions to the vocabulary words. Example number 1, describing an arithmetic sequence. Describe the pattern in the sequence, then find the next 3 terms in the sequence. So we start with 100 and it goes down to 93, 86, and 79. So to go from 100 to 93, we're adding negative 7. From 93 to 86, we add negative 7. And from 86 to 79, we add negative 7. So the common difference is negative 7. So to describe the pattern, we start with 100 and add negative 7 repeatedly. To find the next 3 terms, they are 72, 65, and 58. Pause the video if you need more time to copy down any part of this example. Don't forget to jot down any questions you might have. Example number 2, describing geometric sequences. Describe the pattern in 2, 6, 18, 54. Find the next 3 terms. Well, to go from 2 to 6, we multiply by 3. To go from 6 to 18, we multiply by 3. 18 to 54 is also multiplied by 3. So the common ratio is 3. So we start with 2 and multiply by 3 repeatedly. Well, 54 times 3 is 162. 162 times 3 is 486. And 486 times 3 is 1,458. So the next 3 terms are 162, 486, and 1,458. Pause the video if you need any more time to copy down this example. Example 3. Describe the pattern to find the number of squares in each figure. Is the resulting sequence arithmetic, geometric, or neither? So in the first one, we have 1 square that makes up the figure. In the second one, we have 4 squares. So we've added 3 to get the next term. For the third figure, we have 9 squares. We went from 4 to 9, so we added 5. For the fourth figure, we have 16 squares. We went from 9 to 16, which we added 7. So we start with the number 1, and we add consecutive odd numbers. So first we added 3, then 5, and so on. The sequence is neither, because we're not adding the same number, we're not multiplying by the same number. Pause the video if you need any more time to copy down this example. Don't forget to record a question that we can answer in class. Let's try quick check number 1 together. Describe the pattern in the sequence. Find the next 3 terms. Well, our sequence is 44, 35, 26, 17, and 8. When we start with 44, we go down to 35, we're adding negative 9 or subtracting 9. We go from 35 to 26, again, adding negative 9 or subtracting 9. 26 to 17 is adding negative 9 or subtracting 9. And 17 to 8 is negative 9, adding negative 9 or subtracting 9. So, to describe the pattern, we start with 44 and add -9 repeatedly. Then we can find the next three terms. Take 8 minus 9 or add -9 and we get -1. -1 plus -9 is -10. And -10 plus -9 is -19. So the next three terms are -1, -10, and -19. Pause the video if you need to copy any of this down. Number 2, describe the pattern in 1110. Find the next three terms. Well, when we take a look at 1000 to 100 and 100 to 10, we are actually multiplying by 1/10 repeatedly, or dividing by 10. So we start with 1000 and multiply by 1/10 repeatedly. To find the next three terms, we're going to continue that. So 10 times 1/10 is 1. 1 times 1/10 is 1/10, 0.1. And 1/10 times 1/10 is 1/100th, 0.01. So the next three terms are 1, 0.1, and 0.01. Pause the video if you need more time to copy down this example. In the first sequence, we have 1, 2, 6, and 24. We're trying to find a pattern. There is a pattern because you can take 1 times 2 to get 2, 2 times 3 to get 6, and 6 times 4 to get 24. So there's definitely a pattern that we can establish, but it's actually neither because we're multiplying, but we're not multiplying by the same number. So it's going to be neither. For 1b, we have 2, 3, 6, and 11. To go from 2 to 3, we are adding 1. To go from 3 to 6, we add 3. To go from 6 to 11, we're adding 5. So again, there's definitely a pattern there. We're adding odd numbers and increasing that, but it's neither arithmetic nor geometric because we're not adding the same number every time. For C, we have 10, 9, 8, and 7. In this example, we're actually adding -1. So we're adding -1 to 10 to get 9. 9 plus -1 is 8. 8 plus -1 is 7. So this is an arithmetic sequence. I want you to try these next three additional problems on your own. Describe the pattern and determine the next three terms. Then identify if it's geometric, arithmetic, or neither. So try all three problems. When you're done trying, or pause the video to try them. When you're done trying them and working them out, then start the video again to check and see how you did. If you're doing this on Edmodo, please send me a message or post how you did on these three problems. If you're watching this on a DVD, just keep track. If you make a mistake, copy the correct answer done in red or ink or another color, just so that I can tell how well you did on these three problems. Good luck! For number 1, to describe the pattern, we start with 2 and multiply by 4 repeatedly. The next three terms are 512, 2048, and 8192. This pattern would then be geometric. For number 2, we start with 15 and add 1, then 2, and then 3, increasing by 1 each time. The next three terms are 25, 30, and 36. This sequence would be neither. For the final problem, start with 47 and add -3 repeatedly. The next three terms are 31, 28, and 25. This sequence would be an arithmetic sequence. Pause the video if you need any more time to copy down these problems. Don't forget to report how well you did on Edmodo. See you in class and have a great day.